So in lesson 5.4, we're going to work with using graphs, and it's very, very important to be able to understand what graphs look like and how to interpret graphs. And so here we see graphs are often used to visualize the relationship between variables, and then you may then be able to recognize patterns more easily. So here we have a table. This is the growth of a largemouth bass. And so after a year, it's 6.5 inches, 2 years, 11 inches, 3, it will be 14 inches. When it's 4 years old, it grows to 16, 5 years old to 17, and 6 to 17.5. And we see it keeps increasing over the years. So that's something we can notice, but let's see if we can see any other relationships or see how it's growing over the years. Will it just keep growing forever and ever? And if it's a 20-year-old thing, be 8 feet long or something. So we're going to take a look at that and see what happens. So what you can do here is you can graph each point on here. So I have a graph here for you. Sometimes you'll have to make up your own graph. Just make sure you pick good things for your x-axis. It only goes up to 6. So here this went up to 8, and that actually leaves some room for us to make some predictions of what might happen later on the size of the bass. And then our length, we went from 0 all the way up to 18. So this is going to be pretty close to the top up here. So 1, 6.5 would be here. 1, 6.5. I don't know why it keeps doing that. And then we have 2, 11. So that would be here. So 1, 6.5. 2, 11, 3 is at 14. 4 years, it was up at 16. 5 years at 17. 6 years at 17 and a half. So notice here, obviously, this 0, 0 is here. Obviously, if it's not born, it's not any inches long, or hatched, I should say. And so we can see this progression. It is increasing, but it's not increasing as much as it gets older, kind of like humans. Once you get to a certain height, you're full grown in your height. And so what we could do is, here's the points listed there. And then we could draw a line or a graph through there. It wouldn't be a line, lines are straight, but a curve there to show what that would look like. And now that we see that, it looks like this is going to taper off, and you're not going to have anything a whole lot bigger than 18 inches. Maybe it gets above 18 inches somewhere, but this is average, and so it'll kind of taper off and stop growing after that. And so we should be able to take information, put it on a graph, see a trend, and maybe even be able to describe why that trend is happening. So up here, mathematical modeling, the process of graphing data to study the shape of its distribution. And so we're going to be graphing data that we have in order to figure out if we can study the shape of the graphs, the points on there, and see if we can really use that to predict what might happen later. And that's what this first one shows here. The example 1, model the first class postage rate data. So here's the postage rate, the year, and how much it cost in cents for a first class piece of mail. State general characteristics of the rate of increase of postage over the years. Predict what the postage rate will be in 2050. So we could graph each one of these points. I actually have them graphed already that I'll put up there, but in 1865 it was 6 cents. Then it actually dropped down in 1885 to 2. In the early 1900s it was 3 cents. 1960s it's at 4, 65 is 5. So there really wasn't a huge increase in these almost 100 years here. 75 was 13 and it worked its way up, and then since 2000 it's gone up 11 cents, which is 14 years, and it might even be a little bit more now. But here, if you look at 14 years, it went up 1 cent. And here from 3, this is 30 years, it was still at 3 cents. So you can graph this. So here's all the points here. here it was at 6 cents to start with, dropped down, and then worked its way up. And we see this kind of hops around, but what we want is maybe what's called a trend graph. And so we want to see what's happening. So it's going up, and then it really starts to increase quite a bit. And so we could draw a line in there or a graph in there to show that. So there's a graph of that connecting all those points. And then it says predict the postage rate. So here it says predict what the postage rate will be in 2050. Well, as we look at our line here that comes up, it looks like in 2050, looks like it's going to be about 80 cents for first class mail. So to answer the question predict, we're saying, okay, it looks like it's going to be 80 cents in 2050 because we're following this trend here. It seemed like this trend stopped. If we would have looked at it in 1965, we might have thought, oh, well, this is just going to maybe go like this, and in 2050, it's only going to be maybe 12 cents, but it really started going upward here. The next couple examples talk about this idea. You must be able to interpret data represented on a graph and to analyze the general relationship between the variables. So here we're given a graph. We should be able to look at this graph and kind of talk about what's happening on this graph. And so example 2, use the distance time graph to answer the following question. So let's just take a look at this first. Here is the distance fallen compared to the number of times, or the amount of time in seconds. So there's a skydiver jumping out. What's happening to his distance that he falls? Well, how far has the skydiver fallen after 10 seconds? So what we're going to do here is after 10 seconds, he's fallen, so this is 1,000, 1,100, 200, 300, maybe 1,300 feet. So it's giving us a time. We're able to find out how far he's fallen. How long does it take for the skydiver to fall 2,000 feet? Well, now we're going to look over here at 2,000 and we're going to see, well, when did he get to 2,000? Well, he got to 2,000 maybe around 13 or 14 seconds. So 13, let's say 13 and a half seconds. The next one, and this really gets into understanding the graph a little better, describe the fall of the skydiver in the first 5 seconds, the next 15 seconds, and the final 10 seconds. All right, well, in the first 5 seconds, that's from 0 to 5, what's happening here? Well, you see this is a little bit curved. He's falling, and it's getting steeper, so he's actually falling at a faster rate. So this is when he initially jumps out of the plane. Right when he leaves, he's really not moving fast at all, but the longer the time goes by, he starts dropping faster and faster. And then he hits this rate right here, which it looks like he's dropping the same rate for a while. This is probably his free fall. So he falls for a while. He gets up to a certain speed, and I don't know what you know about physics, but after you get to a certain speed, you don't keep going faster because of what's called terminal velocity. It has to do with the air resistance on you. So he's falling at the same speed for a while, and then what happens here after these next 15 seconds? Well, he doesn't want to die, so he pulls his parachute and he starts slowing down. He's not falling as quickly, and then maybe he was 3,300 feet in the air, so now he's hitting the ground and he's not going to travel anymore. But so that is how we could interpret those different time sections. So here's his initial jumping out of the plane, starting to fall faster. He falls at the same speed for a while, pulls his chute, and does not fall as quickly. The next example actually doesn't have numbers here. it's an unmarked graph, and that's okay. We can still use this to interpret. So this is talking about a family. The Wadsworths spent a day hiking in the mountains. Mrs. Wadsworth has a GPS-enabled sports watch. It records her heart rate and position, including altitude. Analyze the following graphs produced from their trip and describe their hike during each period labeled by a capital letter, so each period of time. So A, B, C, D, E, and F. So these correspond to each other. So here's her heart rate. And so her heart rate starts here and it increases right away. And so this is in part A, she starts her walk, which makes her heart rate increase, and then she's going uphill at a steady rate. So her heart rate is up. So in section A, her heart rate is up because she's going uphill, which is hard work. Uphill. We know she's going uphill because her altitude's changing. She's getting higher and higher up the mountain. So uphill, which is a hard walk or a hard hike, and her heart rate is high because as you're doing exercise, your heart rate increases. As we look at our time B, this could be a couple different circumstances, I guess. They're staying at the same level here, so their altitude's not changing. So maybe they hit a flat spot, or maybe they took a rest. I would say it's probably taking a rest because her heart rate really dropped quite a bit back to normal, really. So they took a break. Her heart rate went down to normal. So part B, they took a break. Heartbeat went down. Heartbeat to normal. Now part C. Part C, their altitude's descending. So they're going downhill. So which means their break's over, her heart rate goes back up, but it's not as high as it was here when they're going uphill because going downhill isn't as hard. So part C is downhill. Her heart rate is up, but not as high. Moving on to part D. Part D, going uphill again. It's actually, this uphill is steeper than this uphill. It might be a little hard to see, but it is steeper, so it's probably harder. So in part D, her heart rate goes up again. So steep hill, whoops, steep hill. Heart rate's way up because she's working extra hard. They go uphill, and here we have another flat area, so they're either staying at this height or they're taking a break. And if we notice her heartbeat, it goes back to normal, so it looks like this is another break time in section E. And so that's going to be the same idea. The heartbeat is back to normal. I'm just going to be HB, heartbeat is normal. And so they went up this mountain, and now we look here and they're descending down the mountain. They didn't have to take any breaks or anything, so they're descending down the mountain, which she's exercising again, so her heart rate's back up, but it's a lot easier than going uphill. So we're going downhill, and her heart rate is increased but not as high, so same as this right here. And so we can interpret those graphs by thinking through what's going on with the altitude and the heart rate and figure those things out. And that is important to be able to read graphs. You see graphs in finances, you see graphs with weather, all kinds of different things where you need to see graphs and recognize what's going on there. So that's lesson 5.4, and you can work on your assignment.